All right, so what we have here is the thinking review questions for the hepatic insulin resistance. So prior to checking your answers, you were to try to provide your own response, and then we can check them here. So the first, again, you have the pathway here, you have the question here, and then again, I reiterated the question, and then here's the results and the rationale. So the first question is, what would happen to hepatic glucose production and blood sugar if an individual lost weight? Well, a decrease in body weight is going to cause an increase in adipose tissue insulin sensitivity. So it's going to improve the person's insulin sensitivity, which is going to then decrease the number of free fatty acids that are circulating in the blood. Therefore, a reduction in free fatty acids in the blood is going to essentially decrease steps 3 through 12. All of this would not occur, and it would allow for the insulin signaling cascade to remain healthy. And therefore, you would still have IRS1 and IRS2 would be able to cause or be activated if insulin were to come in and attach to the insulin receptor, and therefore it would reduce gluconeogenesis and glycogenolysis, reduce hepatic glucose output, and decrease blood sugar. So you'd have a decrease in both hepatic glucose production and the blood sugar. What happened if you increase SOX? Well, you'd have an increase in both hepatic glucose production and blood sugar. And the reason for that is an increase in SOX is going to cause an increased amount of the IRS1 and 2 that would be blocked. Also, it would increase the amount of SHREP1C, leading to a decrease in the amount of IRS1 and 2 mRNA, reducing the amount of new IRS1 and 2s that would be made. And therefore, this would decrease the insulin signaling cascade, which would decrease, or which would therefore the insulin signaling cascade would not work, and therefore gluconeogenesis and glycogenolysis would be upregulated, causing an increase in hepatic glucose output and an increase in blood sugar. What about an increase in fat intake? Well, an increase in fat intake would lead to an increase in obesity potential, but certainly an increase in adipose tissue insulin resistance and the number of free fatty acids that are circulating in the blood. Increases in free fatty acids in the blood would upregulate steps 3 through 12, causing a blockage of the IRS1 and IRS2 and the insulin signaling cascade. And a decrease in insulin signaling cascade would cause an increase in gluconeogenesis and glycogenolysis, and an increase in both hepatic glucose output and an increase in blood sugar. Number 4, what happens if someone were to take metformin? Well, metformin is going to take the place of insulin, so that's going to cause a decrease in hepatic glucose production and blood sugar. And that, therefore, it's going to cause a decrease in gluconeogenesis and glycogenolysis, a decrease in hepatic glucose output, and a decrease in blood sugar. Number 5, what would happen to increase moderate aerobic exercise? That would decrease both. It would cause a decrease in obesity potentially, or at the very least, it would cause adipose tissue to become insulin sensitive, which would reduce the number of free fatty acids in the blood, which would reduce steps 3 through 12. A reduction in that would then allow for IRS1 and 2 of the insulin signaling cascade to be active, causing a reduction in gluconeogenesis and glycogenolysis, reducing hepatic glucose output, and decreasing blood sugar. So make sure you review these. If you missed a few, make sure you review the notes and the video to make sure you have a good understanding as to why the think and review questions are the way that they are.